Hello and welcome to OJM_TV. I believe you enjoyed last week's lesson. If peradventure you encountered any challenge, like I said some time ago, you can put it in the comment section and I will attend to you. Today we shall still discuss the BEC past questions, but specifically on numbers, that is powers of numbers, which is also termed as indices. Good. Let's get to know the general rules of indices. Now, the general rule 1 of indices states that when multiplying like bases, add the exponents. Example is clearly stated there. 5 exponent 2 times 5 exponent 4 equals, of course, we are going to maintain one base, which is the 5, and add the exponent. And so 2 plus 4 becomes 6. I believe that is clear. Good. Let's take the second rule. The second rule states that when dividing like bases, subtract the exponents. Subtract the exponents. When dividing, we subtract. When multiplying, we add. And so, like you can clearly see on our screen, 2 exponent 7 divided by 2 exponent 3. Here, we maintain the base 2. And subtract the exponent, and so 7 minus 3 will give us 4. Good. Let's take the third rule. The third rule says that when raising a power to a new power, multiply the exponents. When raising a power to a power, multiply the exponents. Like you can see, 3 exponent 2 exponent 4, or 3 raised to the power 2, everything raised to the power 4. Here we maintain the base, which is 3, and multiply the exponents. Hence 2 times 4 will give us 8. That is the third rule. The fourth rule says that any non-zero number raised to the power of 0 equals 1. Yeah, 5 raised to the power 0 equals 1. The next thing, 1000 raised to the power 0 is 1. 1 billion exponent 0 equals good 1. That is it. Just keep this rule. Understand everything and you are good to go. You can solve every question as long as you keep this rule. Let's take the fifth rule. The fifth rule says that a negative exponent indicates taking the reciprocal of the base raised to the positive exponent. We have here 3 exponent negative 2. Basically, just write 1 out of 3 exponents positive 2. I believe that is okay. So if I'm giving 5 exponents negative 2, it becomes 1 out of 5 exponent 2. I believe that is okay. So these are the general rules of indices. If you comprehend everything here, trust me, you can solve every question under indices. Let me give you some few seconds to go through again. Good. Now let's take some few past questions. Question number 1. It says that evaluate 2 exponent 7 times 3 exponent 4 times 5 exponent 3 all out of 2 exponent 3 times 3 exponent 2 times 5 exponent 2. Good. We can solve this question using 2 methods. We are going to apply 2 methodologies as far as this question is concerned. The first method will be that we will write 2 7 times. Of course, 2 exponent 7 means 2 times 2 times 2 are 7 times. Then 3 exponent 4 means 3 times 3 times 3 times 3. Same applies to 5 exponent 3. It means we are going to repeat 5 3 times. When we come down there, that is the denominator, we are going to write the same thing. And so 2 exponent 3 means we should write 2, repeat it 3 times. 3 exponent 2, repeat 3 2 times. And then 5 exponent 2 means 5 times 5. I believe that is clear. So let's have that on our screen. That is what we have on our screen. So we can see that the values on the numerator, we have 2, we have 3 and 5. For the 2's, we have 7 2's. The 3, we have 4 3's. The 5, we have 3 5's. And when we get to the denominator, we have 2 3 times, 3 twice, and 5 twice. I believe this is simple. Now we need to simplify it. So let's just cancel. Let's just apply the basic principle. That is by cancelling. So the top will cancel it now. So the first 2, good, like you can see on the screen, we'll take the other 2 down there. I believe that is okay. So they are gone. Now let's take the next 2. We'll take the other 2 down there. Good. Then the third 2 should also take the third 2 at the denominator. I think we have exhausted the 2's at the denominator. Now we need to get to the 3. So let's go straight to the 3. So we will leave the 2's, the remaining 2's at the denominator, we'll leave it there. Now let's get to the 3's. So the 3, let's cancel the 3, and then the down, let's come to the denominator, cancel the other 3. Let's go to the numerator, cancel the 3 there, the denominator, cancel the last 3. Like you can see, we have exhausted the 3's at the denominator. So now let's move to 5. I like the way you are following. So 5, numerator, cancel the 5, and the denominator should take the other 5. Then go cancel the next 5, and then let's start fetch the down there. Good. Now we can see that we are left with 2 4 times 4 2's, and then 3 times 3, and then we have 5. So let's repeat that down here nicely. So we have 2 times 2 times 2 times 2 4 times, then times 3 times 3, then times 5. I believe that is okay. And so let's multiply this. 2 times 2, that will be 4. 4 times 2, that will be 8. Now 8 times 2 will give us 16. Good. 16. Now 3 times 3 will give us 9. Then times our 5. When we pick our calculator, or we employ the lattice method to simplify this, we can just say 16 times 9 times 5, and the product of that will be 720. Perfectly executed. Perfectly executed. I believe you understand this. Good. Okay, let's take the alternative method. The alternative method, of course, the question is repeated. Now, like we discussed earlier with the rule, let's look at the rule. The first rule, when multiplying like bases, add the exponents. Here, when we look at what is there, we are not multiplying, but we are dividing. So that it means the second rule will apply to that. When dividing like bases, subtract the exponent. And so 2 exponent 7 divided by 2 exponent 3 will maintain one base, and so we'll say 2 exponent 7 minus 3. Then our multiplication will be there. So look at what is on the screen there. So 2 exponent 7 minus 3 times, now we have 3 exponents 4 out of 3 exponent 2. Here we maintain one base, we maintain just the base and subtract the exponent. We are subtracting because there is division and we just went to discuss the rule, and so we maintain the base. So 3 exponent 4 minus 2, then times 5 exponent 3 divided by 5 exponent 2, the same rule, maintain the base 5, then the exponent becomes 3 minus 2. Good. Now let's perform that operation. So we will have 2 exponents 4 times 3 exponent 2 times 5. Of course, 5 exponents 1 is the same as 5. Now let's then expand 2 exponent 4. 2 exponent 4 means 2 times 2 times 2 times 2. And then 3 exponent 2 means 3 times 3. So, and then our times 5. So let's put that there. I believe you can see that. Now let's find the product of that. 2 times 2 will give us 4. 4 times 2 will give us 8. 8 times 2, that will be 16. And so we have 16 times 3, that will give us 9. And then our times 5. We find the product of 16 times 16 times 9 times 5. Everything will give us 720. Like the other one, the same thing. I believe that is okay. So we had 720 earlier, and the alternative method is also giving us 720. So you can employ any of the methods and you'll still get your answer, as long as you follow the rules religiously. Follow the rules religiously. Good. Let's take the next one. The next one, that will be our question number 2. It says that we should simplify 2 exponent 6 divided by bracket open 2 exponent 2 times 2 exponent 1 bracket close divided by 2 exponent 5. Good. There is a rule here. We need to employ the rule. Look at what's in the bracket. We can multiply. We are multiplying there, and so Indices says that when multiplying like basis, add the exponent. When multiplying like basis, add the exponent, and so we'll have 2 exponent 6 divided by 2 exponent 2 plus 1, then divided by 2 exponent 5. I believe that is okay. Now let's add the exponents. So we'll have 2 exponent 6 divided by 2 exponent 3 divided by 2 exponent 5. That is impressive. Now there is something happening here. We are dividing, and fortunately for us, the bases are the same. And so what do? Indices says that when dividing like bases, maintain just one base and subtract the exponent. Good. And so we have 2 exponent 6 minus 3 minus 5. Of course, here we can see 6 minus 3 will give us 3 minus 5, that will give us negative 2, and so we'll have 2 exponents negative 2. Remember, we read something earlier. Good. What did we read earlier? That is the 5th rule. Let's go and look at the 5th rule. The 5th rule says a negative exponent indicates taking the reciprocal of the base raised to the positive exponent. Good. Look at the example given there. 3 exponent -2, and at the end we got 1 out of 3 exponent +2. We need to apply the same idea in what we are solving there. So let's go back to our question. Here we can see 2 exponents -2. So what would that be? Good. That will be 1 out of 2 exponent 2. Good. And so 2 exponent 2 means 2 times 2. And 2 times 2, what would that be? 4. And so our final answer becomes 1 out of 4. Good. Good. I believe you love what we're doing. Good. Now, let's move to the third question. Let's move to the third question. The third question says that express 8 times 32 times 4 times 2 in the form 2 exponent m. Okay, I says that using your answer in I, state the value of m. This is very simple. Let's take our time and solve it step by step. Good. Let's take the 8. The 8, we need to simplify it so that 8, 32, 4 and the 2 itself will all have the same base. And so when we find the prime product of 8, that will be 2 times 2 times 2. So 2 times 2 will give us 4. 4 times 2 give us what? Good, 8. And so it means 8 will have 2 3's. So we'll have 2 times 2 times 2. So that becomes 2 exponent 3. Now, and the same applies to 32. So we will say 2 times 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 2. Of course, I know it's many, I know it's lengthy, but we simplify the 8. Later simplify the 32, found the prime product of it, and then the 4, the prime product, and then the 2. So at the end, we have 2 exponent 3, that is for 8, 2 exponent 5, that is for 32, 2 exponent 2, that is for 4, and then the 2 exponent 1 is for the 2 itself. I believe that is okay. I'm going to explain the prime product using the next question, and so just keep calm, you're going to get that clearer. Now, of course, we need to multiply the whole thing, but remember, indices says that when multiplying and the bases are the same, just maintain one base and add the exponents. That is a rule. You have to stick to the rule. And so here we'll have 2 exponent 3 plus 5 plus 2 plus 1. Of course, everything will give us 2 exponent 11. Now we need not to simplify 2 exponent 11 because it will help us in solving II. You get it? Look at II. It says using your answer in I, state the value of m, and look at look at the I. Can you see the I? Express 8 times 32 times 4 times 2 in the form of 2 exponent m. 2 exponent m. And now I can see 2 exponent 11. So I can see 2 matching with 2, m matching with the other exponent. So let's just compare. So comparing 2 exponent 11 to 2 exponent m, we can boldly say that m is equal to what? Again, that is it. So this implies that m is equal to 11. Oh, so simple a question. Let's take our fourth question. The fourth question says that what? It says, this is very simple. It says, simplify 2ab exponent 2 times 3a exponent 2b. Oh wow, this is one of the easiest question. But when students see this question, I don't know why they get frightened. Let me simplify this question. Now you can see that we have 2 and then we have 3 at the other side. So let me just find the product of 2 and 3. So look at it. 2 times 3, what would that be? Of course, you can see it on the screen, 6. Now, the next thing, let me bring the a and then the other a square. Let me bring them together. So a and then the other a square, of course, indices, we are multiplying and the base are the same. So we maintain one base, which is the a, and add the exponent. Somebody will say, sir, but that we have a times a square. How come we are getting a exponent 3? We are getting a exponent 3 because the a itself is exponent 1. The a is exponent 1. And so the examiner will be silent on that. You have to be smart to know that there is 1 there. And so we maintain a, just 1a, and then add the exponent. So 1 plus the 2 will give us 3. Same will be applied to the b squared times b. And so b squared times b. Of course, the b, we have b exponent 1. So we maintain one base, which is the b, and then add the exponent, which is 3. This is actually not what the examiner is looking forward to. The examiner says we should just simplify 2ab squared times 3a squared b. So we need to merge everything. So merging everything, I'll first take the a, attach it to the a exponent 3, and then b exponent 3, and that becomes the answer. So this whole thing here, that is the 2 times 3 equals 6, to the b squared times b equals b exponent 3. The examiner does not need that. This is what the examiner needs. That is a 6a exponent 3 b exponent 3. Is that clear? Good. I love the way you are following. I love that. Let's take the next question. But take notes, if you encounter any challenge, just put it in the comment section like you always do, and I'm going to help you there. Let's take our 5th question. We are about ending very soon. The 5th question, what do we have there? It says simplify 15 exponent 9 divided by 15 exponent 7. Of course, this one, you can see something there. Should I give you some time to solve this? Okay, 30 seconds, let's go. Welcome back. So here, of course, the rule says when dividing and the bases are the same, you can see 15 and then 15, just maintain one base and subtract, because here we are dividing, so we need to subtract. So we have 15 exponent 9 minus 7. So 15 exponent 9 minus 7, what would that be? 15 exponent 2. And 15 exponent 2 means 15 times 15. And what would that be? Good. 225. I believe that is what you got. I know, right? Nonetheless, if you couldn't get it, I believe you get it now. Good. Let's get to our 6th question. Our 6th question says that if a exponent 6 divided by a exponent 4 equals 64, here we are asked to find the value of a. Good. Let's simplify that. Now, there's division there, and the bases are the same, so maintain one base and subtract the exponent. So we have a exponent 6 minus 4, which is equal to 64. So now let's find the difference. The difference becomes a exponent 2 equals 64. Now the 64, we can just find two same numbers because of a square. We can find two same numbers which when multiplied will give us 64. Two same numbers which when multiplied will give us 64. What would that be? 8 and 8. So 8, 8, 64. So we have a squared equals 8 times 8, and 8 times 8 means 8 squared, and so a squared equals 8 squared. Of course, the square will take away the square. What I will have with the a, so a is equal to what? 8. That's all. Very simple. Very simple. Very simple. Good. Should we take the seventh question? Good. I love that. The seventh question says that find the value of m given that m equals bracket open 3 exponent 6 divided by 3 exponent 4 bracket close times 27. Of course, I told you earlier that I'm going to explain the prime product. So let's take the 27 and find the prime product or the prime factorization of 27. Good. So the prime factorization of 27, good. That we'll pick prime numbers, you know, which when multiplied will give us 27. Prime numbers which when multiplied will give us 27. And what we can see here is 3 times 3 is giving us 9. 9, 3, 27. 9, 3, 27. Of course. So how many 3s do we have here? We have 3 3s. Are we getting it? I love the rhyming. 3 3s. Good. And so instead of 27, we are going to use 3 exponent 3. I hope that is okay. So we will now have m equals 3 exponent 6 minus 4. I believe you understand it. 6 minus 4 because we are dividing. So and the base are the same. Maintain one base and subtract the exponent. Then times, instead of 27, now we are going to substitute that with the 3 exponent 3. I love the way you are following the whole thing. Let's perform that operation there. So our m equals 3 exponent 2 times 3 exponent 3. Of course, the bases are the same. The bases are the same. So maintain one base and add the exponent. So here we have m equals 3 exponent 2 plus 3. We can boldly say that m is equal to 3 exponent 5. I believe that is okay. Good. The question number 8. It says that what? If 2 exponent 2x equals 8, what is the value of x? What is the value of x? Okay. We shall use this is going to be our last question. Okay. Good. But before we solve this question, I want you to find the prime product or the prime factorization of 8. Prime product or prime factorization of 8, meaning pick prime numbers which when multiplied will give you 8. Prime numbers only. Prime numbers only. Do that for me. Just 10 seconds. Let's go. Good. And so we have 2 times 2 times 2, which is equal to what? 2 exponent 3. So 2 2 is giving us 4, 4 2 is giving us what? 8. And so we have 2 exponent 3. Wow. So in this question, instead of using 8, we are going to use 2 exponent what? 3. Good. And so we have 2 exponent 2x equals 2 exponent 3. I believe you're okay. Now the bases are the same. Here the bases are the same, so we have to let go of the base and now deal with the exponent. So here we have 2x equals 3. I'm giving you 30 seconds to simplify this for me. Let's go. Good. Now we have 2x divided by 2. Of course, we need to divide both sides by the coefficient of x. Divide both sides by the coefficient of x, and the coefficient of x in this question is 2. And so we have 2x divided by 2 equals 3 divided by 2. Now our 2 will cancel the other 2. Good. What are we left with? We are left with x equals 3 out of 2. Good. Now I want you to solve this question and put the answer in the comment section. Solve this and put it in the comment section. I'm proud of you. Thank you so much for your attention, and if there's anything, you can still put that in the comment section and I'm going to attend to you. We have come to the end of today's lesson. Thank you. Bye bye.